So welcome to a new chapter, cards and wheels. Quickly subscribe to my channel and then click the bell icon and then click the like button and then click the share button, and share this video to as many friends as you can, and indirectly or directly support me in getting subscribers. If you are a new visitor to this channel, and then search for the red button below this video and then click on that to get a subscription, and click on the bell icon and click on the like button and share button to get the continuous updates from this channel. So let us quickly go to the first slide in this chapter. Like this, so many friends are there, so they have drawn. So look at this, and you have to tell who has drawn the best circle. Okay, so from among them I can say nobody drawn the best one, but this first person to some extent looks better. So this is the best circle which he has drawn or she has drawn. Now, making a circle with a rope, Ariba decided to use nails and a thread to make a circle on the ground. She took a thin rope and tied nails on both ends of the rope. She made a circle with the help of her friend. Look at the picture and discuss and see how they are making the circle. So as you can see, they have used two nails. One nail is tied to the one end of the rope, other is tied to the other end of the rope. This is fixed. The one which is in the middle, I mean this girl, whatever she is holding, it is fixed here. Okay, and the other girl which is holding here is moving. Okay, so if they keep on moving it continuously without bending the rope, I mean the rope should be of fixed length, whatever that is, it should not bend in between, and then if they complete it, it will become a circle. Here it is looking like an ellipse, but actually in reality, if you take a rope and then put one end fixed here and the other end by pulling it with a firm rope, I mean the rope should be firm, and then you have to move it completely in clockwise direction or in anti-clockwise direction. That will bring you a circle, and this rope will become just like the radius of that circle. Okay, so we will see that quickly, what is the radius and everything. So do the activity in small groups. Do this. Encourage the students who are there in your class. So to do this in small groups, each group should take a rope of a different length. See the circles made by different groups. Okay, so one group took a length of 3 centimeters, other group took a length of 2 centimeters, other group took a length of 1 centimeter. And after drawing the circles, which group made the smallest circle? Okay, it depends upon the length of the circle. Okay, so length of circle, whose rope is not circle here, the length of rope, whose length of rope is small, they have made a smallest circle. Which group made the smallest circle? Length of the rope, whose length of the rope is small. How long was their rope? Say for example here, in this case, as we have discussed, it is 1 centimeter. length of the rope is smaller. Okay. How does long rope make a bigger circle? Yes. Why is it so? Because the length, as the length itself tells, it is more, and they are fixing one hand here, and the other end they are moving it in clockwise or anti-clockwise direction. It depends upon that particular length. So because the length is more, we are going to get a longer rope. So can you also make a circle with rope and nails like Ariba? Yeah, we can do that. Say for example, if this is the one nail which is fixed here, and the other nail which is fixed at the other end. If we keep on drawing, with a dashed line like this, so this is giving us 1 centimeter circle. Assume that this is a circle. Okay, if the rope length is more, longer, then in this case we are going to get a bigger circle like this. No, it is not correct. The space is not sufficient here to draw this much bigger circle. So let me take some other measurement like 2 centimeters, and it will be 2 centimeters here up to here. Okay, so let me draw with a dashed line like this, because it is not possible to draw with. Okay, this is how we will get a 2 centimeter circle, that is a circle with nails which are fixed at 2 centimeters, or otherwise in this 1 centimeter only you can see 1 centimeter up to here. So 2 centimeter one will be like this. So if you keep on rotating this, then it will be bigger than the 1 centimeter circle. So that's where the question answer for this question comes. Does longer rope makes big circles? Yes. Okay. Why is it so? Because the rope length is increased here. That means the radius of the circle also increased, and as the radius increases, the circle size also increases. Okay, we will discuss what is a radius in the next slide. So the length of the rope used is equal to the length of the radius of the circle. So this is a perfect circle, which you can see here drawn in blue color, and the radius is measured. The radius is pointing. This is the radius. The length of the rope itself is called as a radius. Okay, so now what is the radius of the smallest? What is the radius of the smallest circle here? So take a scale and then measure it, and then you will get the answer for this question. Take a scale and measure the length. So you will after measuring this, so then you may get the radius of that circle. Use a scale, like how did I shown you here in this. Use a scale and then measure it, then you will be getting approximately the radius of this could be 3 centimeters. Draw the radius of this bangle using a ruler. This is the bangle you have with you, and measure the length. So from here to, you can take any dot on this circle. Take a straight line from here and then measure the distance between these two. So that is going to give you the radius again here. Okay. Now see what your friends have drawn and discuss the length of the radius they measured. Is it the same as yours? So whatever the circle we have drawn here, in this case we have assumed it is having 3 centimeters, and the bangle is having the radius some x centimeters, r centimeters. So take a scale and measure it, and then try to write the correct answer here from your textbook. So because the picture is here, which is in a enlarged mode or in a shrinked mode, I cannot make it exact measurements like how much the radius it is. So 3 centimeters for this I guessed by looking at the what you can say, the line there, and for this I can say it is 2 centimeters. 2 centimeters is the guess. Similarly, you can ask your friends whatever the circles they have drawn, how did they measure, how much the length of the radius they got it. Okay, so now draw the radius of these circles. Guess which circle has a longer radius. Guessing is very easy. So as you can see, it is very clear from the diagram that this is a smaller circle having a smaller radius. This is a bigger circle having a bigger radius. Okay, so guess which circle has a longer radius. So I can say that the bigger one, or blue circle in blue color. Measure the radius of the circles using a ruler. Write the length of the radius. Ruler in the sense scale here. So let us start measuring. First let us measure the smaller one. It is 1 centimeter. You can observe the scale is bending. It is scrolled down, so the dot is not pointing exactly to the first line here. Okay, the first line is supposed to be here. So it is 1 centimeter. So from here I have drawn a line up to here. So that is 1 centimeter. Okay, so 1 centimeter is the answer. And the bigger one, the other one, which is having 1.5 centimeters. Radius of the blue circle is 1.5 centimeters. So did we guess correctly? Which is having the larger radius or longer radius? The blue color one is having the larger radius. It is 1.5 centimeters. It is 1.5 centimeters, not 1 centimeter. Here it is 1 centimeter, right? So just remove that, and then we will move to the next slide. So this is how you have to use a scale and measure the radius. Radius is nothing but it is the center of the circle, from where if you draw a straight line to any point on the circle, the distance between the center of the circle to the any point on the circle, its measure is called as a radius. Okay, so then later we will see what is the other thing which you can see for circle. What are the other parameters which you will be using to check the circle or to measure the circle. So as of now you remember radius only. So radius is nothing but, or radius is the measure from the center of the circle to any point on the circle. We can measure it with the help of a scale or a ruler. From your textbook what they have mentioned, it has ruler. So measure the radius of the wheels of a bicycle or a bullock cart. You can use a thread or a measuring tape. Either you can use a thread or you can use a measuring tape. Are all the wheels of a bicycle or a bullock cart of the same radius? The question is, you can understand it in two ways. One is, are all the wheels of a bicycle, all the wheels of a bullock cart are of the same size or of same radius? Yes. If you compare bicycle with bullock cart, then your answer will be no. Hope you understood how you have to answer this question. Are all the wheels of a bicycle or a bullock cart are of the same radius? No. It is answer is no. If you can compare only bicycle wheels, answer is yes. If you compare only bullock cart wheels, answer is yes. They are same. How can you see? Have you seen a tractor or a road roller, which is the biggest wheel you have ever seen? All the wheels of a tractor or a road roller of same radius. So the tractor or road roller, which you might have seen in the beginning of this presentation, right? So I have shown you a tractor there. It is having a smaller wheel and a bigger wheel. So yes, I have seen a tractor, and I have also seen a road roller. Road roller also have the same smaller wheel in the beginning and bigger wheel at the end. That is, front wheel is smaller and the rear wheel is bigger. So which is the biggest wheel you have ever seen? I have seen the biggest wheel for a road roller only. Road roller. Are all the wheels of a tractor or the road roller of same radius? Here the question is a typical one again, same like the previous one. You can write answer as straight away no. If you can think the tractor comparison, same like how did we made a bicycle. If you think that a bicycle, the front wheel and rear wheel, no, they are of not same size. And for a road roller, front wheel and rear wheel, they are of not same size. So you can write directly answer as no. Okay, we won't get this kind of yes or no here. So I hope here also you understood what the comparison we are making. Are all the wheels of a tractor? No, they are not of same size. Front wheel is different with the rear wheel. Road roller also same. They are of not same radius. Okay, leave about the size, same radius. And then same in comparison of a tractor with a road roller, they are also not same. And you can take one small example here. There are two goats, Kali and Lali. Kali and Lali are tied to two poles with ropes. Kali has a longer rope. Kali is having a longer rope. You can see the size of the rope is this much. Okay, and Lali is having a smaller rope. Who can have a more grass to eat? This is a very simple one. It can move in 360 degrees, and she can surround the complete circle and eat the entire grass. But this poor Lali, she cannot do that. She will be getting only smaller circle. Okay, unfortunately both of them got tied to the same rope. If it might be very good example if they have tied it to the different poles. Okay, so here they both are tied to the same pole with two ropes, one of course, but still you can say that Kali can get more. Kali has a longer rope and Lali has a lesser rope. Who can look for more grass to eat? Kali can take more grass to eat, provided Lali allows Kali to have it in the nearby surroundings of that particular pole. Okay, even then also Kali will get more grass to eat. Okay, because it is covering a larger distance when compared to the Lali. So like that, in the real time examples also you can find out where these concepts of mathematics will come into the picture. So we'll stop here. So before stopping, so let me quickly ask for subscription and click the bell icon. So even if you have not yet subscribed, even now at this point of time also, so I request you to please subscribe now by clicking the red icon in this video below, and then click a like button and then click a share button. And please visit my website HANU7.com, and you can also watch my rest of the playlists. You can by landing on this home page of my YouTube channel. You can follow me in Facebook page where I am posting all these videos, whatever I am recording on a day-by-day basis. You can also reach me in other social media platforms like Twitter, LinkedIn, and So that's all for today, and I will take a leave. We will see in tomorrow's session. We will see in next video's session. Thank you.